Hey, well today I went to turn on my computer and this is one of my monitors and turned it on and loud popping noise and this one didn't come up. So I'm pretty sure something in the power supply for this kind of went poof. So let's pop the back off and take a look. So one of the things I like about these is I can put them vertically because they've got the swivel. These are actually, I think these are about 10 years old. I bought them like in 2004, 2005 from Costco. So this is quite interesting. It's got two fuses, hot and neutral are both fused. This is actually pretty. Look at this, they've got pinouts. 5.2 volt standby, power enable. That's convenient. So I should be able to test the power supply unit. So I'm only getting 1 volt. Wait. So it just popped again. But the power light's coming on, which I guess is probably just the 5 volt standby. Something smells very warm. So 150 volts in standby, 387 in non-normal mode. That's interesting. So it's got like a switchable voltage doubler. Just charges down fast, which is nice. I definitely smell something hot. Down to 3 volts, I can. Pulled the cap off here just because I wanted to make sure this cap wasn't bulging, but it looks like it's not. So let's do something kind of stupid. So I'm hoping it'll pop again and I'll be able to see what it is. Okay, got it. So I saw something arc a little bit under that resistor, which is right there. So it's not immediately apparent, but I saw at least some visible, like this lit up a little bit. It looks like there's been some charring down in here. Actually, that resistor might have completely gone self-destructed, because I'm seeing a hole in the insulation. Let's see, so this is red, or I think this is like a 2.2 ohm resistor. Let's see. I can put this in low ohms mode. I have a my Keithley, which has a special mode which uses like a 0.2 volt DC bias for measuring resistance, and the advantage there is it does not bias on semiconductors, so you can do in-circuit measurements with some slight more accuracy. So let's see, where is that part? It is. It is right here. So that is. So that resistor appears to have gone open circuit. I think we have our problem. That is what I'm... Yeah, so that is labeled RMD01. So okay, so here's our resistor. And I'm fairly convinced at this point it's not really resisting anymore. So, click over to ohms mode. And just... Yep, that is an open circuited resistor right there. So, I'm pretty sure that was something interesting was going on. So one thing I noticed is if I look over here, see that black spot? I'm pretty sure that's the composition that just blew out the side. It's definitely punched through the ceramic coating, and then there's some arcing underneath it. So this is red silver, which is 22 by 0.01. So this is 0.22 ohms. Because red, black, gold would be 0.0 would be 2.2. So this should be 0.22 ohms. So what I might do, because I don't have, this is a fairly high power resistor, what I may do to replace this is parallel up 5 1 ohm resistors. So I just went and double checked, and this is indeed, it is indeed 0.22 ohms. So fortunately, for a project I recently did, I bought a bunch of 1 ohm resistors because I was using them for snubbers. Fortunately, I think I used most of them. How many did I buy? I bought 10 and used almost all of them. So I have a bunch of 2 ohm resistors. This may have to be put off for a day until I can grab some resistors from work, unless they're my resistor kit happens to have 2 1 ohm resistors in it. Which it does. Bonus. They're not. So, here are 1 ohm resistors. It's just an idiot check. Yeah, so it's not reading as 1 ohm, but that's so if I actually just go across the leads, we get 0.2. So that is indeed 1 ohm. So what I'm going to do is parallel up 5 of them. I'm going to kind of exploit the little ribbon thing for the moment. So this was also obviously looks like a 1 or 2 watt. I think that's about 1 watt. I don't think it's 2 watt. It might be half watt. These are quarter watt, but since I have 5 of them, it's, you know, effective even for 1 watt of dissipation. It's only 0.2 watt dissipation per, which is kind of on the edge. So this is it's either a half watt or a 1 watt. I'm inclined to think it's a half watt. It did get fairly warm. Maybe I should use those. Yeah, you know what? So I'm worried about dissipation just because basically I prefer a much larger resistor. So what I think I'm actually going to do is I'd have those 10 2 ohm resistors, and I'll just do something funky looking with those. Because that'll give me 2.5 watts of theoretical total dissipation. This, of course, that's, you know, with perfect convection, but hey, more latitude, more headroom. I should buy more resistors. They weren't even very expensive. So, what I'm going to do is make up 2 banks of 5. Which should be 0.5. Now, actually, what I could do is, since it's supposed to be 0.22 rather than 0.2, is I only use 9. So I decided to use 9 resistors rather than 10, because with 9 resistors in parallel you get actually 0.2222222, etc. ohms, which is basically what I want. So it gets my tolerances a little better, which is nice. So I'm going to use 1 pack of 4 and 1 pack of 5. I'll show you what I'm doing in just a second. So there is a 0.5 ohm resistor. So there is my homebrew 0.22 ohm resistor. And actually what I can do now is let's get into that connector. So extend that a little bit. Let's see, what does my pin spacing down here look like? Okay, that's pretty decent. So we have to lap join a little bit of lead on here. Okay. pins, and then so. So I am applying (240 milliamperes). So if I then measure the voltage, well, here, let's just, well, 1 amp, 0.2 ohms is 0.2 volts. It should be 0.2 watts. So I should be able to go up to 1 amp without too much trouble. Yeah, so right now, there you go. There's 1 amp, and we're getting 0.22. So it's pretty much exactly what we'd expect. So our resistance is correct. So I want to clean that grunge up a little bit. So which way do I want to put this in? That way or that way? Okay, if I put it in that way, it hits the capacitor, so it's going to go in this way. So the other thing I kind of want to do is find some heavier wire, because that's going to kind of be bobbly on these. Yeah, one of the things I was thinking about earlier on was actually just using 2 leads, which I think I will do. So what I'm going to do is I'm just going to use 3. I'm going to just lap solder that lead. There we go, that's a much thicker pin. So I'll also see if I can do this right. Solder tension, surface tension should take care of most of this. This is a little challenging because I'm soldering onto something that's just held on with another lap joint. So, actually what I might do is not actually completely lap solder those together yet. So, that should make it stand up considerably more stiffly. They just fit through the holes, which is good. Seat it a little bit. It's definitely a bit wobbly. Also just due to the lack of solder. Alright, that's down far enough. So there's my replacement resistor behemoth, which is just nicely sitting there. So now I just have to go in and put a nice joint there. And a nice joint there. So that's much stiffer. I mean, it's not the sort of thing I'd want to transport, but I'm not transporting this, so bring the lead flush. Where is my There it is. I want to mechanically clear up any flux residue. Just double check everything. I want to pull up a little bit more. There we are. Flattening the leads out a little bit, but it is not touching anything. Kind of little dabs of silicone holding some ferrites up, which are not in the way, but yeah. Anyways. So now that I've done that, now we hope it all goes back together, and that I'm not just. There aren't multiple problems induced by that resistor failure, that it was just that resistor that failed. So, actually I can put it together on the bench. I did previously. Alright, so here is the So this, the power buttons are unfortunately, they're heat staked down, so I can't just pull the board out, which is why I'm doing it this way. So, let's go and insert power. Power off. No popping noises. That was what I'm saying, the LED wasn't on by default this time, but let's go to voltage mode. Put it in VDC, range, and 24.3 volts. So I think it's fixed. That'll be interesting actually. Let's look at our main capacitor. 380 volts. It should now drop down to 150, which is the weird standby system, which is kind of cool actually. Turn it off entirely, wait for that to drop. So it's basically gone. Ha! It's alive! Digital, analog, cannot find input. So, yeah. So, major props to Samsung for building a monitor that I can, literally 10 years after I bought it, when it apparently pops a flame-proof resistor, I can go in and just from the board figure out what went wrong. And, I mean, obviously you can see it's not working. And one of the other nice things is obviously the fact that one part failing didn't cause a cascade failure. You know, there's a lot of situations where you'll have a resistor that goes out or something, and you know, some MOSFETs then get overvolted, and you know, just it blows everything out. Whereas apparently in this situation, what actually seemed to happen is the 24 volt normal supply just wouldn't stay on, presumably because it was sagging or who knows. So it would come on, you know, and then it would fall back to standby, and interestingly enough, the little power LED in the switch was still there. I mean, it's still illuminated because it's obviously run off the 5 volt standby. But yeah, monitor is fixed. I am happy. I didn't have to go. I mean, if I were to do this properly, I'd, you know, buy, you know, a bigger, like a 2 or a 3 watt, you know, flame-proof 2.22 ohm resistor. But this is very much I got home from work at like 8:30, turn on my computer, and this monitor goes pop and doesn't turn on. So it's now 10:59, 11 o'clock, and I have a working monitor again. So this is entirely a fix it with what I have on hand only type affair, because that's what I had to do. I didn't go out for parts. This was just shit I had from some other projects that's now excess. So